Hello, teacher. Hello, students. Welcome to our first lesson on the zeros of a polynomial function. In our last lesson, we learned about the division, remainder, and factor theorems of polynomials. Today, we will discuss the concept of the zeros of a polynomial. If you are ready, students, we will begin. Consider the function f of x equals x minus 1. If the value of x is said to be equal to 1, then f of x equals 0, as we see here. Since f of 1 equals 0, we may say that 1 is the zero of the polynomial function f of x. To find the zero of a linear polynomial function, like f of x equals ax plus b, when a does not equal 0, we find the value of x for which the function equals 0. Let us work backwards. Starting with the statement that the function equals 0, we subtract b from both sides. We also divide both sides by a, since a does not equal 0. Therefore, the only zero of the polynomial is equal to negative b over a, whenever a does not equal 0. We should note, students, that linear functions have only one zero. Quadratic functions of this form have two zeros. To find the zeros of this kind of equation, we must find the value of x for what ax squared plus bx plus c equals 0 when a does not equal 0. Let us try applying these formulas in an activity, students. Here is a polynomial. Applying what you have learned so far in this unit, see if you can find its zeros.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. If you began by factoring this polynomial, you found that its factors were x plus 3, x plus 2, and x minus 1. Therefore, we may express our polynomial as the product of these three factors. This gives us a clue as to the zeros of the function. -3, -2, and 1 are all values of x that would cause one of the factors to equal 0. Therefore, they cause the polynomial to equal 0. Let us test this theory. F of -3 equals -27 plus 36 minus 3 minus 6. This equals 0, so -3 is a 0 of this function. F of -2 equals -8 plus 16 minus 2 minus 6. This also equals 0. Therefore, -2 is also a 0 of the function. F of 1 equals 1 plus 4 plus 1 minus 6. This equals 0 as well. So 1 is a third 0 of this function. We have concluded that the zeros of the function are -3, -2, and 1. Were those your answers? Good job. We can also deduce from this exercise that a polynomial function of degree n has at most n zeros. Now, let us turn our attention to the location theorem. A polynomial function with rational coefficients may have no rational zeros. For example, the zeros of this polynomial, f of x equals x squared minus 8x minus 4, are all irrational. Therefore, we need to be able to find the irrational zeros of a polynomial. One method is based around a function's change of sign. The theorem states, let a and b be real numbers, such that a is less than b. If f is a polynomial function, such that f of a and f of b have opposite signs, then there is at least one zero of f between a and b. Here is an example. Observe this polynomial. How can we apply the location theorem to locate the zeros of the function? Let us construct a table for values of x, like this. If x equals -3, f of x equals 210. If x equals -2, f of x equals 38. In this manner, we can build a table of values for x between -3 and 3. F of -2 is a positive integer, and f of -1 is a negative integer. We can see that the value of f of x changes from positive to negative between -2 and -1. Therefore, by the location theorem, there is a 0 of f of x between x equals -2 and x equals -1. We can also conclude that there are zeros between 0 and 1, between 1 and 2, and between 5 and 6. Let us try an activity, students. Here is a polynomial function. Construct a table of values of x between 0 and 6, and locate each 0 of f of x between successive integers.
Students, let's get ready. Begin. Let's get back to our lesson.
Welcome back, students. You remember how to make a table of values? For example, to find the value of f of 3, we substitute 3 for x and solve the polynomial. 27 minus 81 plus 69 minus 14 equals 1. Therefore, the value of f of 3 is 1. Here's what your table of values should look like. A 0 exists between two successive integers that change signs. Therefore, you can see that f has a 0 between 0 and 1, 3 and 4, and 4 and 5. Great work, everyone! That is all for today. We have learned about the zeros of polynomials and some methods to calculate them. Until next lesson, thank you, teacher. Thank you, students.